Okay, so for our group, since we have 5 people, we decided to do a second video, and it's also the bungee jumper, but we've changed up some of the numbers. So for this problem, we also chose energy lens because we know that the bungee jumper starts with gravitational potential energy, which is converted to kinetic energy, which is then converted to spring potential energy. And for this bungee jumper, we decided his mass is 80 kilograms. So now we're going to find the potential energy, the gravitational potential energy when the bungee jumper is here at this point, when the bungee has not started to tighten, but he's fallen so that the rope is straight. So when we consider the distance that the bungee jumper has traveled at the first point, we want to calculate the gravitational potential energy. We have to consider his center of mass, which is 1 meter from the platform that he jumps off of. So when he's falling over, he's traveled already 1 meter before the 8 meters in the rope, and then another meter to his center of mass when the rope is straight. So now we're going to calculate the gravitational potential energy at that point, and using this equation. So for this one, we're going to consider the height to be 10 meters because it's traveled the bungee jumper has traveled 8 meters, which is the distance of the rope before the bungee, but also the 2 meters to consider his center of mass. So since his mass is 80 kilograms, the mass, gravity is 10 meters per second squared, and the height is 10 meters. So we find this to be 8,000 joules of gravitational potential energy at that point. I'm gonna stop it. Okay. So just to clarify, for this problem we chose downward. The downward direction is positive, so that's why our gravity acceleration is positive 10 meters per second squared. So now we're going to find the gravitational potential energy when the bungee jumper is at this point, when the bungee is just slack, but at the very minimum. So now we're going to solve for the potential energy of the spring once the bungee cord is to its full length, when right before it brings the bungee jumper back up. So at this point, we're going to use the same equation, but for potential energy of the spring instead of gravitational potential energy. And it's the same equation. So we have 80 kilograms times 10 meters per second squared, which is positive because the downward direction is positive. And at this point, the height is 35 meters. And for this, we find the energy to be 28,000 joules.
Yeah, and then now you can erase it.
Now that we found gravitational potential energy and the spring potential energy, we're going to add the two to find the total energy, and then we're going to set that equal to the spring constant. So now that we've found gravitational potential energy and the spring potential energy, we're going to add the two to find the total energy. And 28 plus 8 is 36,000 joules, and that is the total energy. And now that we have this, we can set it equal to the spring constant equation. Which is 1/2 kx squared. And from there, we just solve by multiplying by 2, and then now that we have the equation, we have to find x. And x is just the difference that the bungee jumper has traveled in the y direction. And that would be from the 12 meters to the 35 meters, which we found is 23 meters. So 23 is x. So for this one, we find k to be, once we plug in x and multiply by 2, we find that the spring constant is 136